In part A, we need to show this inequality on the number line. X plus 1 is less than or equal to 4. First of all, we want to solve it to get it just in terms of x. So subtract 1 from both sides and we'll get x is less than or equal to 3. Draw a circle above 3 and colour it in. We want any number less than that, so draw an arrow to the left. Part B, we've got 5 is less than 2y, which is less than 12. We want possible values of y. So first of all, we want to solve this by dividing everything through by 2. And we will get 2.5 is less than y, which is less than 6. Looking at our number line, 2.5 and 6, we can see that our integer values could be 3, 4 or 5. Next, we want to solve this inequality. There's two ways of doing this. The first way that I've seen when I've marked some of your work is that you have subtracted 19 from both sides. When you do this, this gives us negative 15 is greater than negative 3x. At this point, you need to be really careful. If you are dividing now by negative 3, then you need to reverse the inequality. I'll show you why. So if I divide by negative 3, negative 15 divided by negative 3 is positive 5. And then negative 3x divided by negative 3 is just x. And I must reverse that sign because if you think 5, for example, is less than 6, well, I can add a number and that will still hold true. I can multiply by 2 and it was 10 is less than 12. It all still holds true. But if I multiply or divide by a negative, let's say times by negative 2 on both sides, then we get negative 10 here and negative 12. And it is no longer true that negative 10 is less than negative 12. In fact, negative 10 is greater than negative 12 if you think about where it is on the number line. So whenever we are multiplying or dividing by a negative, we need to reverse the sign. And I did see cases where in your work you had managed that, so well done if you'd dealt with that negative correctly. An alternative approach to doing this is to completely avoid multiplying or dividing by negatives, and instead we're going to start with our inequality, and to deal with this negative 3x we are just going to add 3x to both sides. Now we can subtract the 4 and then we are dividing by 3, positive 3. And you see I get the same answer, x is greater than 5, or over here 5 is less than x. These are exactly the same inequalities, x can be anything above 5. The second method here would be my preferred method for you to do. We keep the inequality sign the same all the way through and we just add the 3x. And that way avoid dividing or multiplying by a negative. Question 10, we're given this information and we want to write down an inequality to show it. So we've got that Lee is y years old. Toby is 8 years younger. So we can write Toby's age as y minus 8. The sum of their ages is less than 41. So if I add Lee's age and Toby's age, that's going to be less than 41. If I simplify this side here, 2y minus 8 is less than 41. Okay, part B, the oldest age that Lee can be is I'm going to solve this inequality. So first of all, we'll add 8 to both sides and I will have 2y is less than 49. Divide both sides by 2 to give y is less than 24.5. So the oldest that Lee can be, it can be anything up to 24.5, but we're asked for our answer in a whole number of years. So Lee could be 24 years old. In question 11, Annie, Beth and Carly go shopping. Annie spends £M, Beth spends twice as much as Annie, we can write that as 2M. Carly spends £5 more than Annie, I can write that as M plus 5. The total amount of money spent is more than £60 and we want an inequality to show this. So if I add these three up, these two terms, M is Annie's money, plus what Beth spent, which was 2M, plus what Carly spent, which is M plus 5. That's the total amount of money is more than 60. And then I want to simplify that, and that will give me 4M plus 5 is greater than 60. Each girl spends a whole number of pounds. Work out the least each girl could have spent. So the first thing I'm going to do is I'm going to solve this by subtracting 5 from both sides to give me 4M is greater than 55. And then divide both sides by 4 to give me M is greater than 13.75. But I'm told that each girl spends a whole number of pounds. So the first whole number that is greater than 13.75, M must be 14. So the least that M could be would be 14. So we're going to say Annie spent £14. Beth spent twice as much, so that's £28. Carly spent £5 more, which is £19. In any question like this, I then get to my answer and I want to check it. So we're checking that Beth spends twice as much, 28 is twice as much as 14, and £5 more, 19 is 5 more than that. And then I want to add those up and check they're more than £60. When I add those up, it comes to 61. So it all hangs together.